So in this video, we're going to take a look at two applications of our trig functions. They're going to mainly deal with angles of elevation or depression. So I wanted to point out to you that when we talk about angles of either elevation or depression, we are always going to look off of, or it's going to be based off the horizon or a horizontal line, and we have either the elevation where we're looking up, or we have a depression where the angle would be coming down off of the horizon. So just an important fact that you want to keep in mind. We'll jump in with this first example right here. This example is saying we have some window that is 30 feet above the street, and there's an angle of elevation to the top of the building, which is 50 degrees, but there's also an angle of depression to the base of the building that's 20 degrees. And this diagram over here is showing two right triangles with their angle amounts. And we're asked to find the total height of this building. So since we're looking for the height here, we're going to use trig to be able to find what these values are. We know, because we're given, that the height of my window is 30 feet, and we can label that on this triangle over here, saying that from the ground up until this mark is 30 feet. But what we want to find is this value here. How far is that distance, so to speak, across? We're going to use one of our trig functions to be able to find that. So we typically use sine, cosine, and tangent. Remember, tangent is the one that's going to give us opposite over adjacent. So if I were to write this out, I could say the tangent of 20 would be equal to 30, because that's opposite, over x. And x is what I'm actually looking for. So rearranging this equation, I know that I could rewrite it as x is equal to 30 divided by the tangent of 20. And we're going to let the calculator give us this value here. So rather quickly, I'm going to say 30 divided by the tangent of 20. And I can see that it's 82.42 feet. So that's what x is going to be, 82.42. So now that I know what x is, and let me just write that value in so we can kind of keep up with it here. So this is going to now be 82.42. What I want to find is this value here. How far is it from that line up to the top? And again, I can use tangent because tangent is opposite over adjacent when I'm given an angle here. So the tangent of 50 would be equal to y divided by 82.42. Rearranging this equation, we would then get y is equal to 82.42 times the tangent of 50. Doing that on your calculator, you end up with 98.23 feet, but that's not the total height of the building because we need to add 30 feet to what we've already calculated. So plus another 30, and the height of the building is 128.23, or maybe we want to round this to the nearest foot, and we see that's 128 feet. Okay, so that's really just taking tangent. Tangent is the trig function that really deals mainly with the sides of our triangle. And since we are given sides here, or we're trying to calculate sides as well, that's the one we're going to use. One more example I want to show you here is a different way for us to be able to approach this problem, where we again are trying to find the height of a building, but it's talking about elevation based on the ground. So we know we can see here that Marla needs to find the height of a building. We're given a point on the ground, and she finds that the angle of elevation to the top of the building is 74.2. So I'm going to start out by drawing my building. I'm going to scoot my building over a little. I have a building here, and I know that, so here's my horizon, or the ground, and I know that it's 74.2 degrees from some point up to the top of the building. Then she walks back 35 feet. So she steps back here. 35 feet, and we have a new angle of elevation at 51.8 degrees. So I don't know if you noticed this, but if I were to extend these lines, we can see here that where these two lines intersect is the height of my building. And since I have lines that I'm talking about, I can let the calculator find the intersection of two lines. Now, what equations would we put into the calculator? That's what we're going to discuss. So just so that you can visualize what we have going on here, this is going to be my y-axis. Okay, so this is y, this is x. And remember that a linear equation is given by y is equal to mx plus b. The other thing I want you to remember is that slope is equal to the change of the y's over the change in the x's, y over x. Well, let's put this in terms of trig. What other function do I know of that is y over x? The tangent of some angle is equal to y over x. So I can replace slope with the tangent of some angle, and I could rewrite my equation to look like the tangent of theta times the variable x plus b, but we really don't need that part. So in other words, the tangent of theta is my slope, and then x and y are the variables I need in my linear equation. So let's use that information and come up with two equations right here to be able to put into the calculator. Now, the first equation we're going to take on is the blue line that I have right here. That blue line is centered at the origin. Okay, and I know that that equation, which is going to go on the y1, looks like the tangent of 51.8 times x. That's the equation of that line right there. Now we're going to have another equation given by this red line. But what do you notice about this line right here? Remember back when we talk about, or when you've learned how to graph something from transformations, there's a shift, right? I have horizontal shifts this way, I have vertical shifts this way. Okay, so here my red line has been shifted to the right by 35. The effect would be x minus 35 is how I would write that in the equation. And then we have our slope here, which is going to be the tangent. Better erase that. That's going to be the tangent of 74.2 times the shift where I moved this line out, or I moved this line to the right by 35. Okay, so we have two equations here. I'm going to use that, put them into my calculator. So I'm going to go to the y equals, and I'm going to put these two into the calculator. So here I have both of the equations entered into the y equals, where y1 is my blue equation, y2 is the red equation, but I need to go ahead and change my window. I want my window to be able to show both of these lines, and so I've changed it so that it looks like this if you're doing this at home. -10, 150, and 10 for the x's. -20, 120 for the y's. Now let's graph this and see what it looks like. So I have the blue line there, which again was my my equation here. Then I have the red line here. Notice that those two lines do intersect, and so at that intersection we're saying is the height of my building. So I can do second trace and find the intersection of two functions, which is number 5. So you can see the cursor flashing on the first curve. The second curve is over here, and I don't have a guess. I want it to tell me. And there it is. The intersection is occurring here at 69.45 feet, because we know that the y value is the height of my building. So that's another way for us to use two lines. So we better put the height on here. We know that the height was approximately 69 feet tall, and we used two linear equations. understanding that the tangent of theta can be substituted in for slope, and let our calculator find the height for us.